Hey guys, what's up? Eddie Aho here with KissAnalog.com. So today we are going to continue on with our power supply design series. We're going to add a capacitor. We went through the input circuitry, the bridge rectifier in previous videos. I think this is number 6. Wow. And we're adding capacitors, smoothing capacitors to the output. And we're going to show you the waveforms on the scope. We're going to talk about VA. The fried mule was asking about that. Andrew Johnson, I think, wanted to see the capacitor smoothing this thing out and kind of the progression, as well as some math and how you select some of these parts. I'm not going to do that this video as far as the math and selecting the parts. We'll do that maybe in the next video. But I am going to do that. Right now I'm just demonstrating this stuff, how cool and what you're getting out of it and what to look for. And then we'll, once the hook's set right, then we'll do the math and we'll make that a quick video too, just to say, hey, if you want to pick parts, this is kind of how you do it. But so we're going to jump into this video and show you some waveforms on the scope. I'll show you some power quality readings and what else? I've got the big old bridge rectifier in here now, and all right, let's do it. Alright guys, hope you liked this video. Hey, thumbs up if you do, okay? That helps me. Thanks guys, thanks for watching. Okay guys, so here's the setup. Let's go over the setup again. From previous videos, you're probably used to this by now, but anyway, we've got the AC power coming in here to this little power quality meter. And then through this power cord I made, again, there's no ground connection because we don't need it. We're going to go through transformer for isolation, and I got the Hantek current probe. But what I do is the black wire goes to the switch, a fuse, and then into the transformer through the two primary transformer windings are in parallel. So we got the blue and purple one here. Output is gray and brown. Goes through the thermistor, for inrush current protection, okay, and then back to the red and back to the cord. So that's the primary side. Then this side's isolated, okay, and this winding here there's two windings. One of them I'm not using right now, so what applies to this other winding would apply to this one. So we could have a plus minus output because there's two isolated outputs, okay? They could be 2 plus, 2 minus, whatever. But so I'm using the black and red, and I go into the AC inputs of this bridge rectifier, and I come out of it, and the plus output comes in here, goes to the plus side of this capacitor. So it comes over here to my active load, and I'll show you that in a moment. And I also have the oscilloscope probe connected here. Alright, then the other side of the probe and the active load is connected to the negative side of the capacitor. Okay, let me show you what one of these capacitors look like. Alright, this capacitor is a Cornell Doubler, okay, CDE, and 6800 microfarad, 63 volt. It's good for 85C, but here's the negative terminal. These are definitely polarized. Anyway, so that's aluminum electrolyte capacitor. Okay, let's go up and look at the scope and the active load. It's right up here. Okay guys, this is the GW Instek MDO 2204 EG oscilloscope. Channel 1 has a voltage probe. Channel 2 has a current probe, the Hantek CC65. And so channel 2 is the blue one and channel 1's the yellow. Now, by the way, channel 2, I'm going to start off looking at the current on the AC input, the primary side. Okay, so it'd be AC input, and this is on the load where I showed you before. And we have this Kundin DC electronic load. Basically, it's a variable load. Okay, it's capable of up to 400 watts. So right here's voltage, and this is ohms, where I got the ohm set. You can see right here I'm going to turn up the ohms to I'll turn the ohms up to 100 ohms. Okay, so there's a 100 ohm resistor. and when we get power on it, it'll show watts. And then I use this for on and off. Okay? Alright, so I'm going to go ahead and turn on the power supply. Alright, so here we go. I'm going to flip the switch, just make sure all my wires are not touching anything wrong and everything's connected right. Okay, here we go. Alright, now you notice the current is charged at the capacitor, so there's really not much current there. I could try to zoom in on the current. There's a little bit of current, not much, okay? It's 200 milliamps per division, and the volts are 10 volts per division. So we got 1, 2, 3, almost 4 divisions. So that's right here. It says 38 volts on the electronic load. Now the electronic load's not turned on, so there's no wattage. It's just reading the voltage right now. These are nice little meters. I got that on eBay. I'll show you the price below. That's a nice. I'll do a review on this mirror, or I mean this load. That's a nice load. Okay, right here I have RMS down here in the measurement, 37.6. So 37.8. They're pretty darn close. Peak to peak, it's 800 millivolts ripple. You can't even see it. It's less than 1 volt peak to peak ripple. And we have 22.6 milliamps of current, and peak to peak is 32 milliamps, so you really can't see it. Okay, it's 200 milliamps per range. Okay, so that's kind of what's going on right now. Now I'm going to just turn off the switch. I just wanted to show you something. Now I turn off the switch, but look, the voltage is still up there because there's no drain resistor on the capacitor. There's no load resistor. So normally I'd have a resistor on there. In the real design I will, and it'll slowly discharge the capacitor so it doesn't stay up, because you don't want to go up, especially when you're doing testing, you don't want to go up and touch that capacitor when it has 38 volts on it. Okay, now you can see it slowly dropping. It's 37.5. The capacitor basically has, you know, maybe a mega ohm resistance or something like that. You know, we could calculate it if we wanted to, but it's slowly draining the capacitor, the internal leakage capacitance inside the capacitor. So now what I'm going to do is I just want to show you, when I turn this on at 100 ohms, it'll drain that capacitor pretty quickly. Watch this. And you saw that, maybe you saw that on the screen, that yellow line drop down. So 0 volts. So I'll turn it off. Okay, now let's turn it back on. Now, if this is an audio amplifier, that'd be great. Now, nice solid lines, looks really clean, right? Okay, now let's see what happens when we actually apply a load. Okay, this is 100 ohms. I'll turn it on. Now you see the AC current coming in, that's charging at the capacitor. And right here it says 1.2 volts peak to peak up here. 35.6. You notice the voltage, the RMS or the DC voltage dropped a little bit. But the ripple is 28 milliamps and 120 milliamps peak to peak right here. That's with the 100 ohm. Now right here you can see it's about 13 watts. So that's not very much, right? Okay, let's crank up, let's get a little more power going here. I'll drop this resistor value down. Okay, we got about 17 watts here. I'll go a little faster, go down to 50 ohms. Okay, there's 50 ohms. We have 24 watts. And you can see a little bit more current coming in. Now this current's pretty much running this 24 watts and charging that capacitor. And you can see just a little bit of ripple on the capacitor. It says about 1.6 volts peak to peak. That's only 24 watts. Let's get a little more power. Here we go. Okay, that's about 105 watts right there, 106 watts. Now you see the capacitor charging, discharging. That's what we want to see. That's what we want to show you here. So this pulse charges at the capacitor, the diodes turn off, and it discharges. And then this is rectified, so it charges again, and so we get this 120 hertz up here. Meanwhile, this is about 150 milliamps RMS current, and peak to peak it's 632 milliamps. It's getting close to 3/4 of an amp. We got 4 volts peak to peak up here, and 31.9 volts, or that's 113 watts. Now this transformer's at 250 VA. Okay guys, I had to fix something. I was thinking that current looked too small, so the switch on the Hantek, I found it was a little bit touchy. I've been using it a lot. I don't know if anyway, it wasn't quite set in the right positions. I've done that a couple times now, so I got to be careful. That switch, you may have to make sure it's in the right position. And so here we go. The current is 330 milliamps at 24 watts. That's much more believable. All right, let's crank up the wattage again. Okay, we'll get to let's get to about 100 watts again. Whoops, there's 100 watts right there. Alright, now we got 1.2 amps, 1.28 amps in RMS. Peak to peak, 5 amps. Okay, that much more believable. Sorry about that. I'm just not thinking because I'm videotaping, and all of a sudden it kind of hit me that current looked too low. I was thinking I wanted to put this on the secondary side, and okay, I'm going to move that from over there from the fuse to off the transformer. Okay, now we step down the voltage so the current gets stepped up. So I have to change this. I was on 2 amps per division. Now I'm at 5 amps per division. Okay. So on the secondary side we have 5.6 amps RMS, 23.6 amps peak to peak. Okay, you can see it's 10 ohms, 32 volts. Now let's just watch this voltage. Let's take a look and see how well the transformer is regulating. Okay, so we have 32 volts out. Okay, 32.4, 32.3. These meters are looking like they're tracking pretty well. Okay, now let's just turn off the load. Now nice and clean waveforms. Now voltage jumps up to 38 volts, and then 38.23 over here. Okay, now turn it back on, and 32. So when it's loaded, 10% is about right. But now we have 100 watts. So let's drop the load down. Whoop, sorry, I cranked it up, went up too high. Alright, let's drop the load down to, okay, we're about 23 watts, so 36 volts. See how the voltage is holding pretty steady? We're down to about 15 watts, and it's 36.5. So let's go back up to about 200 watts this time. So it dropped down about 34. Now that also could be some drop in the all the wiring that I have too. Over here the scope is over here closer to the capacitor, so it's not dropping across these leads, because this is 32.6, that's 32.5, so these leads are able to handle this amount of current pretty well. Now you can see how we're really loading that transformer now. Now look, whoops. Look at this. I'm at 370 VA, or 376 watts right there. So the transformer is totally clipping. See that? Let's bring it down. It's interesting that it's clipping just to 1 wave. Okay, now we're at 207 VA. So about 180 VA. You notice that? That's very interesting that it's clipping right there. So about 180 something watts, it looks pretty good. But we're down to 29.7 volts. Alright, you know what guys, something else just occurred to me. You know what, transformer's just warm, doesn't feel hot at all. Alright, so this transformer's at 250 VA, but you know what, that's with both windings. It's not meant for you to take the 250 VA off one winding like I'm doing right now. I mean, that kind of is impressive actually. I took the power up pretty darn high, well over the total rating of the transformer on a single winding. So it's really about 125 watts per winding. Okay, so when I turn this back on and I go to 125 watts, so we saw about 180 something watts. The waveforms look really nice. So let's go to about 125 watts. Now this is ignoring the VA, the input power. See, we're 125 watts. This is output power, and we're 31.5 volts. So if I drop this down to say 100, it's 32.6. Okay, now I'm going to move the current probe back to the input. I want to just talk about this for just a moment. Alright, now at the input, 104 watts on the output. On the input, I have about 1.37 amps. Okay, and that's at 120 volts. Let's calculate that. Alright, we have 1.37 amps in RMS and about 120 volts. Okay, times that, 164 watts in, and we have 105 watts out. Now that's not all efficiency loss. Some of that's power factor, okay? So we're losing some in reactive power in the transformer. Alright? Now here, let me show you the power quality meter and we can see what we're talking about there. But the point is this is already over the 250 VA, because we're really about 125. We should be limited to about 125 VA on the input. Okay? So if it's 125 VA, that'd be 120. Whoops, that'd be 125 inner, and that's 125 VA divided by 120 volts. About we should be about 1 amp, just over 1 amp on the input. Okay, so let's drop this load down to where we get about 1 amp. I'm going to get a little better view on the current there. Going the wrong way. Here we go. Okay, let's go down 1 amp. Okay, that's just over an amp on the input. So now we're back up to 33.4 volts on the output. So that's really the limit of what each winding's supposed to provide, which is about, turns out to be about 80 watts on the output. So your 250 VA, you really get about 160 watts on the output, and that's due to power factor. Okay, now let's go look at the power quality meter and we'll see what that looks like. Now look at the ripple. Now that 33.3, if we add another capacitor, right now we have 2 volts peak to peak ripple. So we could add another capacitor and get that ripple down, right? We could drop that ripple down. Here, I'll add another capacitor. Let's do that first. Actually, we're going to do that next video. Let's look at the power quality meter, and let's kind of shorten this video up. It's probably gone too long. The power factor is 0.765, so about 0.8 roughly. Well, really, you know, each decimal point actually is kind of meaningful, so it's about 0.77, let's say. So that's why, you know, we're losing some of this power in reactive power, and that's why the transformer is rated in VA and not watts. See, we have about 122 volts in. We're about 94.2 watts. So that's real power, about 94 watts. And my Kundin says I'm at 80 watts right now. So we've got about 14 watts loss. That's the efficiency aspect. And there we are, about 1 amp input, and the scope said about, it pretty much agrees. It's 1.01, and this says 1.003. And we have about 59.9 hertz. So there we go, there's the power factor. Now, incidentally, as we lower the power factor gets worse. Here, let me drop that down to, let me drop that power down. All right, so I dropped the power down to 20 watts. It's about 19.7 watts on the Kundin, and our power factor is 0.68. So it gets worse with smaller load. There's more distortion, and the capacitors are more fully charged, and so there's current only flowing during small portions of the waveform, so the power factor gets worse during that. Okay, so 20 watts, this is where the current's just charging just during a portion of the cycle. That's why the power factor is worse. So now when I take the power up, okay, so when I'm taking the power up to, let's say, 80 watts, okay, that's about the max we should really be pulling steady state through the transformer. 250 VA, it's about 125 VA per side, which translates to about 80 watts in output. Alright, so we can get a little bit more power on the output by getting the RMS voltage up a little bit higher by getting rid of some of that ripple. Okay, what I want to show you is the current, what it looks like. That's the current on the primary side. We saw what it looked on the secondary side of the transformer. That's going into the rectifier. So when the AC waveform comes up, and when it's higher than the capacitor voltage, we charge, and when it's lower, it turns off. Okay, now let's look on the capacitor side. Okay, that's what it looks like going into the capacitor. Just wanted to show you that. Alright, and that's my trigger. You can see the line right there. It's really cool how it does that. It's a lot like Siglant. It also gives me an actual readout. I'm really liking this scope. I'm going to do a review on the scope. It's really impressed. Really happy I purchased this scope. So okay, here we are, about 13 ohms, 80 watts. And with the one capacitor, we have 3.2 volts peak to peak at 82 watts. Okay guys, so now we've got the two capacitors in parallel, and we're at 1.6 volts peak to peak now. You can see this current's charging. There's more dead time between, there's less ripple. Well, it's gone up to about 2 volts peak to peak, 33.2, and we're about 82 watts right now. And the Kundin says about 33.3, so it's pretty close to the 33.2 here. The output is 9.6 amps RMS, 4.6 amps. So by the way, when you pick these capacitors, you want to make sure they can handle the ripple current. So we have 4.6 amps out, but peak to peak's 9.6 amps. That's important. Hey guys, thanks for watching. Hope you liked this. If you liked it, thumbs up, okay? That helps. It really does. And let me know what you think and what I should cover, what I might have missed. I really like the input. It helps a lot. And I'm sure everybody else is thinking the same thing you guys are asking. So keep the questions coming, and the comments and the suggestions. Thanks a lot guys, appreciate it.